So tonight's course is residential plumbing, overview for our inspectors. So we're gonna jump right into it and just basically talk about the introduction. You guys could read along. It's kind of broken down into some easy reading. When you're doing a plumbing inspection, you're gonna inspect the various components of the plumbing system, identify the components of the plumbing system, understand how the components of the plumbing system function and perform, and describe to your clients the defects, observations of the plumbing system. So there's a quick overview of what's basically involved in the plumbing aspect of a house. All of these slides are on the InterNACHI website under the plumbing course. So if you folks want to go back and review this stuff, because we're going to kind of buzz through it, and you could reiterate what we do tonight through the courses on the InterNACHI website, which is excellent, by the way. Okay, so one of the main things when we're doing a plumbing inspection is you want to look for these defects. Obviously, leaks, inadequate water supply, water contamination, and incorrect installation of components. We'll touch on all of these as we go through it and talk about how these work on the inspection. So when we're talking about plumbing, that's the definition. Material systems used for piping, fixtures, and equipment that manage your water distribution, drainage, and venting in the proper manner. Potable and contaminated water. Understand potable water is safe for drinking, and contaminated water obviously is something that you're not going to drink. That would be your drain lines and stuff like that. Fixtures are, like we said, toilets, showers, bathrooms, bathtubs, all of that stuff. Also under plumbing, everybody has to remember appliances, dishwashers, clothes washers, water heaters, garbage disposals. Those all fall under the plumbing section of your inspection. Obviously, the InterNACHI standards of practice is what we follow. So this is just some quick highlights on what the inspector shall inspect. Once again, all this information is on the InterNACHI website. Great courses, highly recommend studying up on them to help you out with what we do. Again, you can read straight through water supply, fuel shutoffs, water heating equipment, interior water supplies, all fixtures and faucets by running water, all toilets, operational, attached to the floor properly, sinks, drains, drainage, sump pumps with accessible floats. The inspector shall describe. Now, this is going to be verbally to your clients as well as in your report. Whether the water supply is public or private, that's important. The location of the main water supply shut off, so your clients know exactly where to shut the whole house off if there's ever a catastrophic failure. Location of the main fuel supply, which would be basically your gas shut off, your oil shut off, and remember electric as well, because a lot of houses run on electric these days. So that would be a supply shut off from that standpoint. Even though it's not on the plumbing, it is a shut off. The location and observed fuel storage systems, which basically we're talking about propane tanks, oil tanks in the ground, above the ground. So you want to definitely document all of that stuff. The inspector shall report as needed in correction any deficiencies in the water supply by viewing functional flow in 2 or more fixtures to see how the pressure is. Deficiencies in the installation of hot and cold water faucets. You always want to make sure that hot is on the left, cold is on the right. Mechanical drain stoppers that are missing in sinks and tubs. Silly things like that. We did an inspection one time and the drain stopper in the tub wasn't working. Lady called up and was complaining because we didn't tell her the drain stopper wasn't working. Silly things like that. Don't get jammed up with that. So just kind of follow through on these things and you'll be in good shape. Toilets that were damaged have loose connections to floor. We're talking about that. Go through the videos. They'll show you how to test all these things and how to observe it. Not required. Light or ignite pilot flames. These are pretty obvious. You're not going to determine the size, temperature. Well, Determine the size, temperature, age, life expectancy. That's all up to you as an individual if you want to put that stuff into your reports. I always mention the age because that's one of the things that clients want to know. How old is my water heater? How old is my boiler? Stuff like that. And a lot of times sizes, they want to know the size of it. Interior flues, chimneys, that we can't see. So those are all stuff that you're not required to do, but you can make an attempt to look up a chimney and see if there's any issues with the damper or the flues. You're not going to determine exact flow rate, water quality, sealed plumbing, access panels. You're not going to open that up. Inspect clothes, washing machine, or their connections. We do. It's if you follow the standard practice and you don't do it, it's if you're following the standards of practice and your clients understand, then you're okay. Operate any valves. They're talking about shut-off valves underneath the toilet or underneath the sink, because if you turn them, they could break off, they can get stuck. So you don't want to deal with that. Test shower pans. We're not going to fill up a shower pan. Some people do. Tub surroundings and enclosures for leaks or functional overflow protection. Evaluate compliance with conservation, energy, building standards. Inspect water treatment systems or water filters. Also, determine the effectiveness of the anti-siphon backflow preventer, whether there are sufficient cleanouts, fuel storage tanks. Evaluate fuel storage tanks for supply systems. Inspect wastewater treatment, water storage. Evaluate time to obtain hot water at fixtures. Evaluate and determine the accuracy of combustion air. Right. You're not going to determine adequacy, but if you're looking in a boiler room and there's no combustion air coming in, you might want to comment on that. Test, operate open or closed safety controls, manual stops. Examine auxiliary systems, components, solar panels. Pretty straightforward. Test for gas leaks or indications. Now, you can go above and beyond these standards, understand that. But if you're following the standards of practice, this is what you follow. You can go above and beyond these things, as we discussed already. Okay, so I think I'm going to show this video because it's really good and it's not that long. But the rest of the videos, they're very long. I'll show everybody what they are, and I highly recommend going to the website and watching them.
Public or private, the location of the main water shutoff valve, the location of
I'll fast forward through that because we did that already.
We have the shutoff valve is in. The standards tell us to start in the installation of hot and cold water faucets, active plumbing leaks, and toilets that were damaged, were loose, or leaking, or had tank components that didn't operate.
So we're going to start 3.6, the plumbing portion of the inspection. The standards tell us to start the inspection at the main water shutoff. We are required, if accessible, to state what the main line is and where the shutoff is. So this is a 3/4 inch copper main line. We have the shutoff valve is in the basement bedroom. So that's what my report would say. We actually take a picture of it. That is the only picture in the report that does not relate to a defect. If we have a newer house or a house using a cold water ground, we will typically see a ground wire here. So that's part of the electric, but this is where we start to look. If it's a plastic water line coming into the house, of course, we can't use it for a ground. Above it, you're not required to remove all these. So we wouldn't have known which one was the main, but if they're right next to each other, I'll typically look at both of them. This is actually the shutoff valve for the sprinkler system. If you look close, the main water shutoff is a ball valve. On this house, the sprinkler system is a gate valve. Gate valves are still legal, still are okay. Most builders prefer a ball valve. They have less chance to leak, but you will still see gate valves on your inspections. Plumbing, we looked at the main water shutoff. Now we go to our fuel system. On this house, we have natural gas. So we have a meter. Here's our diaphragm. We should have a disconnect or a shutoff before the meter. On this house, it's actually kind of buried in the mulch. I found it, but It's not supposed to be under grade like that. So I would definitely put a note in my report. You know, the fuel disconnect was at grade, maybe inaccessible, snow weather, something like that. But you're not required to dig it up. If this had been dirt, I definitely wouldn't have done that. But it's right here. That is how you would shut off the gas to the house if it's needed. Again, we are required to tell where that is. Exterior of the house near the gas meter. Now we'll go in the house and we'll look at the water heater. Okay, just coming from the fuel. Now we're gonna come over to the water heater. Was at grade, maybe inaccessible, snow. This water heater is a new water heater. It's a 40-gallon water heater. So looking at this, new water heaters, most jurisdictions are now requiring an expansion tank or an expansion valve. We don't have one because our main water valve, shutoff valve, did not have a regulator. Some jurisdictions don't require it because if the water gets heated up, it can still push backwards. If there was a regulator or a backflow at the entrance to the house, we would need an expansion tank. As we're looking, if it would damage the house, we'd also need a catch pan. But since we have a concrete floor with a drain, we don't need one. Here's our gas shutoff. And again, the drip leg on this one functions both for the furnace and the water heater. We have to have a shutoff on the cold water. We are also required to look for evidence of backdrafting, which would be our exhaust coming into the house. When they have the rubber bushings or gaskets down here, it's very easy to look and see, do we have backdrafting? These both look terrific. So it does not look like we have spillage into the house. Sometimes you will also see a burnt or corrosion on just the inside of one of these fittings. That would also be an indication we're backdrafting into the house. Now, looking here, we also need combustion. Whenever we have a furnace or a water heater, anything that burns gas, we need to have oxygen for the unit. When we're in with proximity to the dryer, most jurisdictions, and we're not code, but basically it says if the operation of a dryer can affect the operation of an appliance, you're required to have outside combustion air. The furnace has its own combustion air. The water heater does not. So I would write this up as a defect that we don't have outside combustion air because we are so close to the dryer. So whenever the dryer, whether it's gas or electric, is on, it pulls oxygen through the house. We don't want it to pull oxygen containing exhaust gases from the water heater. So the issue I see here is lack of combustion air or outside combustion air for the water heater. Now we'll start looking at supplies. So our bathrooms, our kitchen, all of our faucets, things like that. We're done with our water heater. Okay, now we're coming to the bathroom. So we're gonna start running our water. When we come in, we turn on the hot water at our sink. When we come up to the toilet, when these are in the way, we move them, but we always push against the toilet to see if it's loose. We also want to see if they've caulked all the way around the toilet. We don't want to see them caulk the whole thing because if the wax seal leaks, we want to see it come on. Since this is in a basement, or this is the basement bathroom, and it's on concrete, and on concrete, they allow you to caulk it all. So our hot water's hot, cold's cold. So we're gonna let it run and see what we have for leaks. Now, we run a lot of water. I want to see water in here. I want to put a couple inches of water anyway in the bathtub. If it is a shower, we do not plug the stopper and do a water test of the shower pan. It is not required for InterNACHI standards of practice. In fact, it's discouraged because a lot of times if it does leak, you will damage the house. Then you are responsible. So do not do a water test on a shower. Just run it as normal, which is open up the faucet. Now, our stopper is holding. So we will take a picture of the water in there. I'm checking. I don't find any leaks. Now underneath here, typically we want to see water shutoff valves for the hot and the cold. Older houses, it was not a requirement. if we have PEX with a manifold, it's not required. But on most houses, you will see individual shutoffs. Same thing at the toilet. We want to see an individual shut off there. We want to see the toilet tank within 2 inches of the back wall. Otherwise, we're tendency to get leaks. Want to make sure it flushes correctly. So our hot's hot, our cold's cold. We want to make sure our shower diverts correctly. Turns off our water down here. So we have a couple inches. So now we're going to turn this off. So the drain stopper is holding. On this one, it's a plastic, so we don't have tile, grout, things like that to look at. But, you know, so now I will drain the water. Look at the caulking down here. On our electrical portion, we would check our GFCI outlet, things like that right now. But on the plumbing, when this drains, we're done with this bathroom. We always like to come back to the water heater after we run hot water in the bathroom, because I want to hear the water heater in operation. Right now it's functioning. This is where you'll get the knocks if it's full of sediment, different things like that. Now, this water heater has an electronic ignite, just like most newer ones. Remember, home inspectors do not, should not, are not required to light pilot lights. Now, next to this is a washing machine. Sometimes, if there's nothing in here, we will run the washing machine to check the plumbing, but standards of practice say we are not required to inspect washing machines or their connections. Most home buyers expect us to, but our standards of practice say we do not. So if you do it, you are going beyond the standards of practice. Just remember that. Okay, now as a home inspector, we are required to check functional water pressure. We're not required to put a gauge on, but to check our functional water, we turn on cold at the bathroom sink. We'll turn on cold at a bathtub. This is one of our biggest water usage. And then we'll flush the toilet and see if we see a drop. On this house, we're not seeing a drop in water pressure. So that would pass a functional water test, water volume test. So that's how we do it. And you are required to check, have two operating at the same time to check for our water flow. Okay, now we're going to look at our kitchen plumbing. Just like bathrooms, we want to check all our faucets, make sure that hot is hot, cold is cold. So first thing I do is I put it on hot. We want to check both sides. We're going to open our cabinet, let it get hot. Down here, now dishwashers are not part of the standards of practice, but because there's plumbing, we typically look at them. Understand you are exceeding the standards. We don't have anything about dishwashers because every house doesn't have one. But we're going to look at how our waste line is coming. This one actually hooks up to the disposal. Because this is a newer dishwasher, there's a high loop built into it. Otherwise, that line would be wrong because there's not a high loop built into the waste line. Looking at our plumbing coming down here. Now, I like to try and get a look at it, but remember, we don't need to move everybody's stuff. So we don't have any leaks there. Now we'll come over to this side and check it. Make sure our slope is correct. Make sure we have one P-trap, not two. We're going to reach your hand up, make sure that we have a clamp on our disposal wire. Looking at the plumbing here, they could have put a high loop or a standpipe on the dishwasher because it is set up for one. Then we'll go back over. We'll turn on the disposal, make sure it runs. Make sure all functions work there. We don't have any leaks. We didn't have any leaks underneath. We'll turn it off. Now, our reporting should state that the plumbing was not fully visible due to the occupant's belongings, because there was a lot of stuff under here, which is pretty typical on an occupied property. A problem, standards of practice say we do not. We also are not required to operate sprinkler systems. We do inspect attached plumbing, such as the backflow, but anything else is under grade. So you should not operate sprinkler systems. If you do, understand you are going beyond the standards of practice. So By looking for leaks, we're required to report active leaks, corrosion, etc. Poor water flow, where we run multiple appliances. We're not required to check actual water pressure with a gauge. So the big thing is don't do shutoffs. Don't turn things on or off, except for faucets that are made to be operated normally. So that's concluding 3.6, the plumbing section. Now we're going to move on to the electrical.
So that was a great video with Jim because we were talking about a lot of those things. So now you were able to visually see it. So I like that. That was a good one. A lot of the other videos are going to be a little too long to play, but as we go through the course, I'll show you the videos that are on here, and I would highly recommend going back to the InterNACHI website and watching the rest of those videos because they'll be tremendously helpful, just like Jim's video here, to actually see it in real time. So fixtures are pretty much a lot of the things we spoke about. Faucets, showers, toilets, stuff like that. That's all part of the stuff that Jim spoke about that you would be inspecting. Connections and flanges, you're not going to really see that, well, except for the photo on the right. That's a drain coming down, but you're not going to really see the wax seals because the bowl's over it. But you are going to, straddle it. If you see in the lower picture, there's a leg there. You're going to straddle it ever so slightly to see if it's loose. Those are things you're going to report on. This is what Jim was talking about. When you're looking underneath the sink, you're going to look at the trap. This is just the components of a trap. It's always good to know the terminology in the components. So when you have a conversation with your client, you can, speak from an educated standpoint. So those, it's obvious you want to make sure they're not leaking. You want to make sure they're in good shape. Obviously, like Jim said, if there's stuff underneath the sink, put it down as a limitation. Report everything you're doing. If you can't get to certain things, it's really important to put that in the report. This is just temperatures of how quick you can get burnt. If you see when you're running the hot water, if it's steaming and you shoot it with your infrared or thermal imaging camera, identify those temperatures if they're high. You don't have to put the exact temperature, but just say, higher than required or recommended. If they have little kids, they can get burnt real quick. So that's important to know the temperature of the hot water. Overflows, basically, it's gonna help if the sink is filling up. It's not gonna let it overflow. There's usually a piece where the finger is on the inside of the sink, and it's gonna come down. Underneath, you'll look, you can see corrosion, pretty obvious. A lot of these things, you just visually look at it and you'll be able to know if there's a problem and then just document it. Location, pipes, fixtures, equipment, must not interfere with the operation of the doors and windows. These are connections, water closets, different kinds of valves that are involved in the toilet. So this is urinals and bidets, just visual inspection. You can turn it on. You got the plumbing coming up, the requirements when you have this type of setup, all good stuff to know. Wash basins, same thing. Make sure it's secured to the wall properly. Like we spoke about earlier, hot on the left, cold on the right, functional water flow, all important things that as inspectors, these are the things that you are looking for to document and share that information with your clients. Just to reiterate what Jim was talking about, when you're in a bathroom, you're running the multiple fixtures, you're checking to see if you get a temperature drop, a flow drop. And don't forget, if you have a 2-story house, the second floor would be even less pressure than the first floor. If you're having an issue downstairs on the first floor and you're losing water pressure, go upstairs and try to turn it on upstairs. Sometimes it doesn't even come through. So you could document that and visually show it to your clients. They'll understand it pretty easily. Sinks, make sure they're mounted in right. Faucets, make sure they're not leaking. real basic stuff as you're running the water. You're going to see it. You're going to document it, take your pictures, put it in your report, and move on. Food waste grinders, same thing. You could turn them on, let the water run, turn it on, get the switch, see if it's not leaking, if it's connected properly, all of that fun stuff. Dishwasher, these are some of the requirements, not that we're doing anything from a code standpoint, but Jim mentioned the high drip loop, which is important. Some states require the air gap because you don't want the dishwasher to get wastewater from the trap down below. If you look at this illustration, you have the trap down here. If you don't have that high loop, if it's coming down this way and this trap gets filled up and backed up, you're going to get that wastewater into the dishwasher. So when you do an inspection, definitely be concerned that you have the proper drip loop or the air gap up on top of the sink. Clothes dryers. What we look for when we're doing this is to see if there's a standpipe which is connected to the waste stack. A lot of times we do inspections, the hose is in a sink. It's not really the right way to do it because the standpipe is designed more to handle this flow and volume and less chance of it getting clogged. The drain is smaller. It can get clogged. You can wind up with the sink overflowing if you're not down there. This is much safer. We also always check to make sure that this drain is attached to the standpipe somehow with like a zip tie or something like that, so it doesn't fall out and create a flood. So that's something important to look at. And again, this is the anatomy of a drain. So just understand the pieces. If you have to write your report and use some of this terminology, it's good to know what you're talking about. Again, this is exactly what I was just talking about. This washing machine is discharging into the sink. So it's not strapped on properly. You want to make sure it doesn't fall out. So that's kind of what we were talking about a little bit ago. Bathtubs, shower enclosures, you tap around to make sure that the tiles are in good shape, because sometimes it could be hidden moisture damage behind there. Whenever we do a house and we come across tiles where you're tapping on it and you hear them clicking or loose, water got back there. So what I would do is document it in the report stating that, loose bathroom tiles, check for hidden moisture damage. Because once they start taking those tiles off the wall, there's going to be hidden moisture damage in there. So little minor things like that, discuss with your clients to keep it caulked and sealed properly. Those are all important things. Sometimes when you're in the basement and you're looking up, you can see underneath the tub, you can see a lot of the drains. So that's always a good place to look. Water pools and jetted tubs, you check the functionality. What you want to do is when you have these situations, if you look on the right, that's an access panel. A lot of times we'll do whirlpools or jetted tubs or jacuzzis, and they don't leave you an access panel. So if you have to work on the motor or something like that, you can't do it. It's a silly thing. So when you have this type of whirlpool or jetted tub, always look for the access panel. Showers, same thing. When we check a shower, we kind of move the head around. You don't want the water to just run into the tub or the shower pan. You want the water to hit as if you were taking a shower and standing in there, and the water was bouncing off you, hitting the wall, hitting the glass door possibly, and you check outside for leaks after that. Perfect example. Take the hose, the shower head, and let it hit that corner, because if it's leaking, that's the only way you're going to find out. If it was just sitting on the shower head and just running straight down, you're never going to get this effect. So that's important. Make sure the doors are sealed properly. All good stuff. Drains, you want to make sure that they're cleaned out and not corroded with anything, corroding like that, or any kind of, that's a floor drain, obviously. You want to make sure it's kept clear. Water supply, again, these are things, just an FYI to know this. You're not going to state it on an inspection, but just so you know, sometimes you can see things are not done right, so you could comment on it. But this is just good information to know, to keep in the back of your head. Water heater general comments, that's pretty straightforward. Most tanks are insulated steel cylinders with enamel coating on the inner surface. They are referred to as glass lined tanks. The lining helps prevent corrosion. Conventional residential water heaters have life expectancies that vary greatly. That's why we personally do not put life expectancies. You can if you want, but I think it's just you wind up with a situation that you might not want to deal with. But water heaters as space heaters. For water heater has a dual purpose of supplying hot water and servicing a heat source. For a hot water space heating system, the maximum outlet temperature, they get into some specifics. You're not really checking the temperature. You want to just make sure if they're using it as a space heater, that's it's creating heat for you. Sacrificial rods. This is a good comment, that when we come across various water heaters that have these, I think one of the common ones out there is called titanium. You'll see a lot of these on there. And if you look at the label by the sacrificial anodes, I always explain to my clients, I make them read it, because if you come across one of those water heaters, you'll see it says, have it inspected annually, and they'll tell you. So when I talk to my clients, I explain to them, I'm like, when you have your service, just make sure that the plumber is checking this for you, because what that does is this corrodes and deteriorates, and it's exactly what it's called, a sacrificial rod, so it doesn't affect the tank itself. Drain valves, you got there's a way you can drain the sediment from the tank. It's helpful with getting all that debris from the bottom. It allows you to flush out sediment and debris from the bottom of the water heater. Location on these drains are normally towards the bottom. Obviously, that's where the sediment's going to build up. Just on that valve, you check to see if it's leaking or corroding. You're not going to open it up, but you could suggest to your clients, if they want to flush it out, they attach a garden hose and let it go down a drain, etc. Access, water heaters should be accessible for routine inspections, maintenance, adjustments, repairs, and replacement. Manufacturers usually make access recommendations. Access means to be able to reach the water heater by possibly first removing a panel, etc. Accessible does not include or imply the removal or destruction of finished materials, drywalls, etc. Water heater labels. This is a good slide to talk about, because when you're doing your report, you're going to get a lot of data from this tag. You could look at it. There is the model and serial number. It'll give you the gallons. It'll give, well, this is an electric water heater, obviously. But if you folks out in the field don't know how to decode this, because a lot of times the date's not on it, you have to decode it from the serial number. That's important. You folks can download an app. It's called Building Intelligence, and you can go to that website and then plug it in and put the serial number, and it'll give you all the information. Well, I know a lot of people ChatGPT it, but we've noticed that ChatGPT can be wrong sometimes. Building Intelligence is pretty accurate. Tankless water. This is one of the videos that I'm not going to show because it's pretty long, but I highly recommend, if you want to learn about tankless water heaters, go to the plumbing webinar on the InterNACHI website. And this is another good video. But if we have time later, we can go through some videos. But the rest of these videos are pretty long, but they're in the webinar from the InterNACHI. Again, this is the cutaway version of a tankless water heater. What's good about it is to get yourself familiar with the air inlet, the exhaust. You're not going to open this up and start having conversations with your client, but you're going to look for various things, corrosion, rust, things, you just open it up visually and you can see, but it's good to know these things. And if you take it off, you might be able, you might want to point out a couple of these things to your client to share your knowledge and show that, you understand what this is all about when you take the cover off. If you pick 2 or 3 things, point out the gas valve, the condensate trap, that kind of stuff. It's always good to be able to share it. Now, when you're checking the venting on the water heater, you have 2 different types of venting. Actually, we're showing 4 of them here. One is when it's a separate intake and exhaust pipe. It's independent, just like this one here. You have your intake on B and then your exhaust on the red side. This one is a concentric pipe with the intake and the exhaust on the entire run. So this is on the outside, obviously, and it's drawing air in from the back part of this cone shape, and the exhaust is coming out through here. That would be this one here, A. So understand when you're venting it, it's direct vent, and this is the different ways that the tankless water heaters vent. So you'll be familiar with those. Tankless recirculating systems. A lot of times when you have tankless, people add a circulator pump on it, so they have hot water at the fixtures relatively quicker. So you'll see that installed on certain applications of water, tankless water heaters. When you're inspecting tankless systems, again, we just spoke about it. You want to check to have proper venting. The water temperature, we talked about that earlier. You want to make sure that it's not too hot. And in the same token, you got to make sure you got hot water, because that's our job when we go there, to make sure that you have hot water, because it's a necessity. So those are things that you would check for on just like a regular water heater, even though it's tankless, the functionality of it for the hot water and, scalding aspect of it. Again, another very long video, but great. I would highly recommend spending time going on this and watching it. If we get through the slides and we have time later, we could jump back and look at some of them. But more importantly, I want to get through the meat and potatoes of the webinar, and then you folks can all look at this at a later time on your own. But great videos. The guys do a really good job. Tankless coils from boilers. Understand that some boilers have the coil inside of it, like, didn't we have a, yeah, okay. So this is more in the field practicality. You can see that's a coil going inside the boiler. So tankless coils used for heating home steam or a hot water boiler produces domestic hot water as well. No separate water heater tank is used. Understand that, because when you go to a house, you might not have a water heater, but you're going to get your hot water through the coil on the boiler. So you would explain to your clients that in the summertime, your boilers are to kick on to give you hot water in the house for, your faucets and sinks, domestic hot water. And then obviously the one we looked at before was on demand. And again, on these inspections, you look for corrosion, you see if there's any leaking, that kind of stuff. And a lot of times you'll see this, if the coil fails, then they'll redirect it to a water heater and they'll close this up. When you're inspecting a water heater, depending on the location, it's important to know these things, especially if it's in a garage. So that this is a gas-fired water heater in a garage. There's the section at IRC. It tells you exactly how, not that you're going to state the exact inches and stuff, but you can comment on it if you don't have that space. If you have a water heater or a boiler, any gas appliance in the garage, it should be elevated. Confined space and combustion air. Again, that first video we watched was great. Jim talked about combustion air. If all combustion air is taken from the inside of the dwelling, then you're using up the oxygen in the house. So anytime there's combustion air, there should be some type of combustion air coming into the space where the gas appliances are. Also, a lot of times you'll see a metal flue coming down, and it's just an opening, but it goes to the roof, and it has obviously a cap on it. They're using that for fresh air. We call it fresh air intake or combustion air. So those are some of the important stuff. And then there's specifics, you're not going to get that technical, but it's good to know it, because if you have those numbers in the back of your mind and you walk into a space that doesn't seem right, at least you have in the back of your mind, that the parameters are not proper. Depending on your area, seismic supports. I know here in New York, we don't do that, but clearly out in California, they do. So sometimes plumbing inspections are state specific. So everybody should be familiar with their state requirements. So that's pretty straightforward on that. Water valves and tanks. What you want to do with a valve should be installed on the cold water branch from the main water supply to each hot water storage tank or water heater. Jim talked about that again. I highly recommend everybody going back and looking at that video again, because he does a good part of the plumbing inspection in a good short period of time, and you'll understand all of this stuff. The valve should be easy to access and locate near the water heater, because you want to be able to shut that off in case there's a problem. The valve is to be installed. If the water heater is taken out of service, you got to be able to shut the water off. You don't want to have to shut the whole house down. So this is kind of like an isolation valve. Dip tubes inside the tank. Not that you're going to see it, but it's good to understand how it functions. Typical design of a water heater tank includes a water dip tube. The tube directs the cold water to the bottom of the tank, because that's where it's getting heated. And as you draw water off of the water heater, it comes off the top. So pretty much common sense with that, to drop the cold water to the bottom. And that's the function of that drip tube. Fuel shutoffs, all part of our inspections. Again, documented. We like to state it in our report, showing where the valves, the shutoffs are, and all of those kind of things. It's important. Again, we talked about earlier, a shutoff can be electric for the plumbing because it's a water heater. That would be the shutoff for the water heater for fuel source, because electricity is a fuel source. So you have the picture on the left is the shutoff valve for the gas. And then, of course, you have the temperature setting on the regulator on that section, which you can close off also. TPR valves, great picture with the illustration. We do not operate these. Do not operate them, because they'll stick and you'll get stuck in that position. You don't want to deal with that. You do want to check that it's not leaking. You want to make sure that you got the extension pipe coming down to whatever, like 18 inches off the ground. But again, common sense, if it's 16 inches or as long as they get it down to where if you're standing in there and this thing releases, you're not going to get hit in the chest or the abdomen with it. You want that to be directed down to the floor at the lowest point possible. And again, most water heaters have this statement on it. Discharge pipe, we just talked about that, part of the inspection. You're going to look for that and make sure it's there. Make sure there's no threads on the bottom of this pipe over here. because then when it leaks, sometimes people just screw something on it to keep it from leaking, and you defeat the purpose of it. Very, very important on that aspect of it. Should not be threaded on the bottom. If it is, I highly recommend calling it out. Again, you got the pressure relief discharge tube. That's pretty much the safety mechanism for the TPR. You have it on the boiler, you have it on the water heater. Let's see, it says 18 inches from the floor, but as long as you know that it should be lower to the floor. Expansion tank on the boilers. The boilers and water heaters. Hot water heaters should be provided with an expansion tank. There's two types of expansion tanks designed for use on residential boiler systems. Non-pressurized is a simple cylinder filled with air set at the atmospheric pressure. A pressure tank is sealed, cylindrically divided by a flexible diaphragm. That's what you're looking at here. Right above the label here is that diaphragm we're talking about. And you can tell because one section is going to have air and the other section is going to have the water. You tap on it and you'll hear a distinct difference between the two. The expansion tank provides space for the water to expand as it's heating and keeps the water pressure within the normal operating range while the boiler is working. So you can always, tap it and listen to the sound. You'll know that if they're both got that don't have that hollowness to it, then that means they're full and it could create a problem. Water leak catch pans. You see this a lot when the water heaters are on a floor up on top. You don't want it to leak down. If it's in the basement, you don't really see these, but the more so like in condos, if you have a water heater and it's a multiple floor, you'll see that. In the basement, some people do it, or it's just there's a floor drain right there. They're not too concerned with it. But again, you could inspect it if it's there, if it's rusted or clogged or anything, you just call it out. These are some of the defects that we look at when we're checking for the water heater part of the inspection. Check for physical damage to the tank, particularly rust and corrosion on the bottom of the tank. Check for watermarks on the floor. Obviously, if the tank's leaking, you'll see it. Inspect the TPR valve, which we just spoke about. If it's an electric water heater, you make sure that the covers on the connection part where the electric comes in. Again, a lot of these things are visual. You'll see them jump out at you if they're not proper. We talked about tankless coils in the boiler, but again, familiarizing yourself with these components on the water heater is good. That you use them in your report. You can reference them. You could talk to your client, be educated. Again, this is a good cutaway view of, and here's that sacrificial anode we were talking about. Some of them on the top, some of them are on the side. I think the titaniums are on the side, but those are things that you would inspect as part of your water heater inspection. Again, another video, I believe this one's pretty long too. But again, if we have time, we'll go back and look at some of these at the end. But these are all on the InterNACHI website, so highly recommend giving it a look. Water pressure, these are the things that would affect it. Obviously, we just talked earlier about the size of the pipe, the material, which would cause friction, changes in direction, pressure, and elevation. So those are all things that would affect, like we were talking about, if you were doing a functional flow test and you turn the water on downstairs and you went upstairs and you turned it on, it would drop even more. Sometimes you don't even get any. But the amount of pressure lost caused by friction is affected by velocity of the water, roughness of the water, the developed length of the pipe, and the diameter of the pipe, which we talked about how if you increase from 1/2 inch to 3/4, it's a big difference. So these are just some of the things that would affect it, affect the water pressure. water pressure fixture velocity. With an increase in velocity comes an increase in friction. Makes sense. Roughness, a scale will build up on the inner walls of the flow supply pipe. That's what we were talking about. If you have a galvanized drain, a galvanized water supply, it's going to just start deteriorating and shrinking down and causing, they're referring to as roughness, but it's going to restrict the flow. And the more changes in direction you have, it's more resistance on the pipes, it's going to affect the flow. Elevation, obviously, the higher up you go, it's going to be less flow, water pressure defects. In order to get the most meaningful results in the relationship to inspecting the water pressure, is good practice to inspect the plumbing fixtures. We just talked about that at the highest point, correct? So second floor, third floor, wherever you're going, you'll see a change in pressure. Oh, back to this again. I guess this is important. We're at it again. So talked about the 1/2 inch and the 3/4, and how that would change the flow. Okay, excellent. Love this video. I love this slide. So we talked about the galvanized water main or steel water main coming in. So what happens here is you could see the rust on the buildup over here. That's what we're talking about with roughness. So it's restricting the flow. That sediment, the rust from the inside of the galvanized drain, water supply, is going to affect the pressure. And then when you're looking at water supplies, one thing to understand is that most leaks occur where the threads are cut into the pipe, because as you look at this picture, you can see when you're threading a pipe how it cuts into the thickness and the diameter of the pipe. So a lot of times when you have galvanized supply lines, you'll always see corrosion or leaks, usually at this point. Sometimes there's a defect in a pipe and it'll leak elsewhere. Also, if there's dissimilar metals, if you have a steel pipe and you have copper straps, it's dissimilar metals, it's going to corrode. Be on the lookout for that. But this is a great illustration of a galvanized pipe and how it would affect the water pressure and accumulation of rust on the inside, etc. So that's, I like that picture. Length of pipe, pressure losses relative to length of pipe. Pretty straightforward. 10 feet of 1/2 inch diameter pipe. There would be a pressure drop, 7 PSI. Elevation, obviously dwellings built far above street level may have low water pressure. You even if it's, like the second floor of a house, or on the other side of the, second floor on the opposite side of the house, because now you're going through a lot of more turns and bends, you might get a lower water flow. So again, pipe length, elevation, dirt, sometimes these particles in the water supply reduce water flow. A lot of times what happens is when you're at the fixtures, especially like at a sink, they have that screen on the bottom of the faucet. A lot of times we'll open the aerator, we'll open up the supply, and there's a low flow, but the flow was great throughout the house. A lot of times underneath, if you unscrew that filter and clean it out, it'll change the pressure, because all of the sediment that's in the pipe is going to be affected by that. Water consumption, again, these are just, what you would get at a shower head, a sink, a urinal. Not that you need to know it, but it's information. Federal law mandates that the sink's faucet have to have a minimum flow of, like they're saying, 2.2 at 60 PSI. If not, it's not going to function properly. You're going to write it up anyway. You're not going to figure out the gallons per minute or anything like that, but you'll see restricted flows, the shower head, the sink, the toilets. You would definitely comment on that. Size of water supply pipes to fixtures. These are, standards they go by. Sometimes they're bigger size pipes. Water closet flush valve. Yep. important point on the bottom, if it's going through a manifold, individual distribution pipes, it can be reduced because it's going through there. Again, another bend and turn on the supply line. This is the thermal expansion on the water supply. Sometimes you have, again, it's similar to the expansion tank on the water heater. And then of course you have the watts regulator that that handles all of that pressure. I just want to get that information on that one. Right, in the connection of the water distribution system to the water heater appliances, there is a potential for migration of heated water into the water distribution piping. In a typical water distribution system, the water will expand into the public water system. Expansion is not accommodated in this system. So when you have the backflow preventers, when you didn't have them, the water would be able to move within the water main. Now that you got these backflow preventers and all that other stuff, you're kind of isolating the system. So if it gets overpressurized or backs up, it has to go somewhere. So that's the idea of the expansion tank, because you can compress air, you can't compress water. So the water would expand, push on that diaphragm, and it would compress the air, and it'll kind of keep things in balance. Same thing with the, that's the thermal expansion tank. And you got the Watts valve for that as well. Everything to control the expansion of the water. So we talked about EPA ban water and lead solder joints, because people didn't realize as you were using solder, there was lead in it. The big thing is, on this is the water supply line. If it's a lead water main, that's where you're going to have your most amount of lead in your water supply. Although the solder and stuff did create these problems, because if you're not using water, it's sitting in the pipe, not moving, and the lead is leaching out into it, and then that's where it creates the problem. They say if you have a lead water main, run the tap for 2 minutes, it's going to clear it out, but it's all your level of comfort when you have a lead pipe, but it's our job to call that out if we see it. So make sure you know how to go about inspecting a lead water main. If it's coming through the house, everybody should be, know how to do that. That's important. Pipes used for water distribution is required to conform to NSF 61. Used for distribution of hot water must be compatible with standing high temperatures. All hot water distribution pipes and tubings must have minimum pressure of 100 PSI at 180 degrees. The maximum temperature of a hot water distribution system is 180. CPVC, PEX, and PB plastic pipes are often identified and rated for 180 degrees Fahrenheit at 100 PSI. The pipe can actually withstand temperatures to exceed 212, but that's what they're limiting it to. And that's the water distribution pipe. Solvent cement joints, solder joints. Let's see. Through this. Okay, so solvent cement joints for chemical bonding between the PVC pipes. You'll see the blue primer on it, and then they glue it. So you'll see certain things like that. Solder joint. A solder joint is the most common method of joining copper pipes and tubing. Again, you saw on the slide before that they banned lead in that, so there's no more lead in the solder joints. So it's safer if the water's sitting in there. And not running. When copper pipe is joined with galvanized steel, protection against galvanic corrosion is needed. That's what we were talking about earlier with the supply lines. If you have a galvanized drain or supply line and you have a copper strap, it's going to create this galvanic action, which is basically the two dissimilar metals that also can create electrolysis and react metal in the joints and anodes. That's why you have the anodes in the water heater to help with all of these things so it doesn't attack the liner of the water heater. Dielectric fittings and brass fittings would be a way to eliminate the galvanic corrosion between those two dissimilar metals. Valves. Okay, so in this, you have different kinds of valves. Fully open valves are shut-off valves that in the full open position have a straight through flow passage. What I always tell my clients is when you see, you see the hand on the valve, if the handle is in line with the pipe, that means it's in the proper position, it's flowing. When you turn that valve a quarter of a turn, it's perpendicular to the pipe, it's off. Like in this case, it's covered, you really can't tell. But on the handle, a lot of times they'll have on and off in a direction you have to do it. So this is a good illustration of a ball valve. One thing that we do a lot of times on the water supply line, if you have an old gate valve, we put in the report that we state the fact that they're difficult to operate. They might not function when you need them. So I always say to my clients, when you have a plumber here and you're doing a punch list, have them install a ball valve on the upside of the gate valve. So if you have to close the whole house off, it's much easier to do it with this ball valve than a gate valve. I've heard people trying to turn the valves and they snap, and it's just a nightmare. And remember, they're going to be 50, 60 years old, so you're not going to want to play around with them. All the new plumbing, they use ball valves now. So that's important to call out when you're inspecting the plumbing, the water supply on the plumbing line. Look for these valves and identify the water main shutoff for your clients so they know exactly where to look for the valve if they ever had to shut it off immediately. Shutoff valves should be installed on the water supply pipe to each fixture, other than showers and bathtubs. But they might have shutoffs like downstairs in the basement if you had to shut it off. On the water supply pipe to each sillcock, on the water supply pipe to each appliance or mechanical equipment. So that's what we were talking about with the water heater. You have a shutoff there. You got to be able to shut things off if you have to remove things and replace them or work on them. So that's important to know that the valves are at the point of use. And of course, we never operate them. Okay, this is exactly what we were talking about. This is a great illustration of, you got a ball valve, a globe valve, and a gate valve. So you can see the difference. If you could see it on the slide, the ball valve, when you turn it, it's that stainless steel ball that literally just closes up the water flowing across. With the gate valve, you're turning it and you're pushing that gate down. So there's, you got to keep on turning it as opposed to a quarter of a turn on the ball valve. The gate valve, you're pushing down on a threaded piece inside, and those fail. And of course, you have the other type of valve where it seats in, and that's even, a little more difficult to operate. So those, they don't really use that much as shutoffs. You do see them. The newer styles are much better, but the ball valve is pretty much, a lot of the plumbers, it's the go-to for them. Hot water, we talked about that earlier. Check the temperature. If you see that it's very hot, comment on it. It's important to know what the temperature is. You don't want anybody to get scalded. If you have little kids in the house, they can get burned relatively quick. So that's important to identify any of that needs to be corrected. And most importantly, that you have hot water. It's our job when we go there to make sure you have hot water in the house. And on the same side, that you don't want to get scalded from it. General comments and testing standards. What we're talking about here is, that you're gonna run all the drains, make sure it's functioning properly, and then point out if they have cleanouts in these sections. If there's a problem with, this is a drain line, that you have a clean out there. The third slide, the second slide on the right has the clean out on the side, so you open it up. Plumbing fixtures and appliances include fixture traps. Above ground drainage piping is what we're looking at now. Below grade drainage piping, that's underneath the slab, you won't see it. And below and above ground venting systems and piping to public sewers or private septic. So this is going out, this is a drain line going out. You got your clean out. Again, down here you have it. Those are important things to look at and make sure they're not leaking, and accessibility to be able to clean out that line. You need those. Trenching should have solids and continuous load bearing support. Bottom of the trench forming a bed on the rocks. This is explaining how that you would do, if you were doing trenching, how you would do it. Pipe is protected from damage by proper backfill. This is all stuff that's underneath the ground if you're putting drain lines or water lines. Now we're getting into sewers and sewer treatment. So now we're going to be dealing with the aspect of getting rid of wastewater in your house. So I guess this is what the slide before that, when we were talking about the trenching, they're referring to this. When you start laying the pipes, the trench must provide solid, continuous load-bearing support on the bottom, which we spoke about. Avoid pressure points, rocks or uneven surfaces. Backfill should be placed in the 6-inch layer. Tamping it down every 6 inches. Material restrictions, make sure there's no large rocks, chunks of dirt. Not that you're going to be doing this, but it's, it's good to understand how they do it. And then this is a good illustration of the plumbing, where you have your traps leading down into the public sewer or cesspool, your vents going up, vent stacks. I'm going to get into a little more detail on that later, but this is a good illustration to understand that the yellow is the public sewer, the blue is the building sewer, and then the drain. So you have an idea how everything's interconnected. Sanitary drainage pipe material. These are the different materials that are used for drainage. If it's PVC, cast iron, we spoke about that. You have copper, you have polyethylene, polychloride, stainless steel, all of those things that you have to know if they're permitted or not, depending on your area and location. Sometimes these things vary, but that's the sanitary drainage pipe materials that are used. And you can see down in the basement, obviously you have that cast iron drain being supported by a strap. Then you have another one coming off that's galvanized. So those are the things that you would call out and look at them. Those are old type of drains. Slope of drainage pipe. These are you follow this if you're doing a drain line or whatever. You just want to make sure if the slope is too much, then the water is going to run down and the solids are going to stay behind. If it's not sloped enough, then everything's just kind of going to be hovering there and not flowing down. So there's that. That's why they give the exact, if the size of the pipe, the minimum slope, if it's 3 to 6, if it's 3 to 6 inch pipe, you're doing a 1/4 of an inch per foot, etc. Just so you kind of know. And that's the type of thing you look at visually. If you see the sewer lines, inside the basement, and sometimes you see that the slope is too much, what happens is the solids stay behind. So that's important to understand that and comment on it. If it's not sloped enough or too much, you kind of get an idea. Changing drain pipe size. The size of drainage pipe cannot be reduced in the direction drainage flow A reduction will create an obstruction of flow resulting in blockage or stoppage. That's pretty much, not only the size is, you take into consideration the size and the slope of the drain pipe. Okay, these are some good pictures. This is clearly the picture on the right is a breakage on a cast iron sewer line. And then you have breakage. This is corrosion. You'll see all that stuff, cast iron and especially galvanized, they rust from the inside out. You could be looking at a galvanized drain and it looks perfect. But if you do a cutaway section of it, you'll see that it's really clogged up. But this is obviously a breakage in the cast iron line, and then this is corrosion. So you'll identify those two when you're looking at anything that's visible that you could look at from the drain standpoint. You'll comment on any deficiencies there. Again, this is how plumbing joints and connections are made. Different types, the combination, the quarter bend, the combination, wear and sweep. Just you kind of know sanitary tapped T, you know what that is. And then this is a good illustration of what it should look like and what it shouldn't look like. So it's good to understand why this, the functionality of it. And again, familiarize yourself with all of this stuff. Great illustration. Prohibited joints. The following joints and connections are not permitted. Cement or concrete joints, that's mastic or hot poured bituminous joints, joints made with unapproved fittings, joints between different diameters of pipes made with, joints between different types of plastic pipes made with solvent, and saddle type fittings. So that's all stuff that is not permitted. And if you see these type of things on your plumbing inspection, you should call them out. Cleanouts, we talked about that before. There was a couple of slides before that showed the cleanouts. That's clean out where you can open it up and then clean out any blockage, or if you want to run a camera scope down there, you can. It's helpful for your clients to know if the drain's backed up. That's all good stuff, especially on older houses. I know a lot of people are doing camera scopes as part of their inspection and upcharging it as an ancillary. I think it's a great idea if you can get around to doing it and want to do it. Great, Jim does a great course on that. InterNACHI, you can get all that certification through InterNACHI to know how to use the camera scopes and all of that stuff. So if that's something that everybody or some people want to look into, it's not a bad idea. If you want to invest time and money into it, you can reap the benefits of it. Again, just samples of, this is a PVC pipe going into a cast iron. I'm sorry, no, that's, wow. Okay, so that's galvanized. No, that's PVC with the clean out up top, and they connected it into the cast iron. So just slides for that. Drainage system, sump pumps and ejector pumps. So the purpose of sump pumps and injector pumps are used where plumbing fixtures are below the level of the main sewer line, helping remove wastewater or groundwater from the basement or low areas. So sump pump, you're going to be handling clear water. It's not sanitary waste. It could be, high water table or water coming in. It's not contaminated water. Where on the other hand, sewer ejector pumps, it's dealing with waste. It's dealing with solids. It's grinding it up, pumping it out, and it's being pumped into the sewer system, where the other water that's not contaminated, just we call it could be gray water, you can discharge that outside. Sealed system, sewer ejector pits must be airtight and vented to prevent sewer gases from escaping, and must discharge through a check valve to stop backflow. So what we're saying there is, when you have, like the picture on the right, you have a pump, whether it's an ejector pump or a sump pump, the picture with the hand on it with the green, that's a check valve. So as the water goes up and it gets past that point and the float stops it from pumping up, the water doesn't go back down into the pump system and just keep on short cycling. So that'll prevent the water from going back in. And then when the pump comes on, it's a one-way valve. It'll push it up and out and you're good to go. Inspection focus, check for proper covers, venting, secure discharge, piping and points, and signs of leakage or corrosion around the pit and the fittings, especially in the sewer ejector pump. If it's not sealed properly, you're going to get a foul odor in the basement, especially when you start running it and testing it, you'll smell it. And if you look at the top of it, you'll see that it's either loose or things aren't sealed properly and the gasket's not good. So you would recommend, someone taking care of that unless you want to smell sewer gases. These are examples of some pumps that are just taking care of groundwater or water coming in attached. These are not such a good application because it's just sitting in the dirt and it clogs everything. Usually what you do is you'll have, like you saw in the other pictures, you'll have on the bottom, you'll have a container or plastic piece in the ground, and it'll just let the water come in and keep the dirt and debris out. This is primitive. And on the slide on your left, you'll see that's the float mechanism. As the water fills up, that pushes up, it trips a switch goes on, pumps the water out, and then finds its way to wherever it's discharging. I would find out where it's discharging. A lot of times we see this, they're discharging it outside right next to the foundation, and it's creating another problem. So be aware of that. If you can operate it, operate them, see if it's working. All good stuff. Drain, waste, vent basics. So basically, whenever you have water, you always need air behind water for the water to flow properly. So the vent system protects the trap seal on each fixture by preventing pressure imbalances that can cause siphoning or allow sewer gases into the house. Each trap or fixture should have a separate vent connected to the main vent system with all vent pipes sloped to drain and a minimum size of 1.25 inches. Types of pipes, waste pipes. Waste pipes carry liquid waste. Waste pipes carry liquid waste without fecal matter. Soil pipes carry waste contaminating. That would be going through your sewer. And the stack is the main vertical drain line serving multiple fixtures. Stacked vent extends above the highest fixture and acts as a main vent, while a vent stack provides additional air circulation to the system. Inspection focus. Ensure vent terminations are unobstructed, properly sized, and extended above the roof line to allow gases to escape safely. You want to have the picture on the left. You could see it's up high. That's the vent. You want to make sure that, if you get a lot of snow, it's not going to, block it or cause problems. A lot of times you'll see screens on the top of these vent pipes. All good stuff. You just want to make sure you got clearance so it can do its job properly. Function of stack, we talked about that. Main difference is that the stack vent is a direct extension that must reach outside. So on this picture, when we're doing our inspection, basically you're going to be on the roof for this one. You want to check the plumbing stack boot. The picture on the left, it's in good shape. The picture on the right, you could see it's deteriorated. So obviously, as it rains, you're going to get water going into the house because this is not sealed properly. So you want to make sure it's stable. You want to make sure that the flashing underneath the roof is attached properly. You don't really want to see nails going through the flashing like that. That's really not a good application. If you look at the picture on the left, there's no nails or screws going through it. The one on the left is done properly. The one on the right, they threw nails down, and you could see they did tarring or caulking around that part. So there's a little something going on here. Call it out, put a comment on it. And obviously that nail is going to rust and it's going to create a leak point in the roof. So again, that's the plumbing stack. Check the gasket around it. Pretty straightforward when you do your roof inspection. Air vents. We talked about that earlier. Individual branch and circuit vents are permitted to terminate with the connection to an individual or branch type air admittance valve. So a lot of times you can't get that vent pipe to go up and out. And especially on a high-end kitchen or a kitchen that has a center island and there's a sink in that center island, you don't want to see that vent pipe going up, into, there's no wall there. It's the open concept center island. So what they'll do is they'll put this, we call it an air admittance or an air vent valve that will allow when water's running, it'll allow that vent to open and draw air in. So again, like I said earlier, you need air behind water to flow for the water to flow properly. So that's important to know. You'll see these on those type of applications in the underneath the sinks. Vent distances. They're talking about the size of the trap. The slope in inches, distance from the trap. Stuff to keep in the back of your mind. You're not going to, you'll visually see when there's a problem. These are good information to know to get educated, but you don't need to know them in the field so much, but you'll pick up on situations like that. Vent terminations, we talked about that. This is another shot of vents coming out of the roof. Vent terminations perfect. Each dwelling must have at least one vent pipe that extends outdoors to allow sewer gases to escape and fresh air to enter the drainage system. Roof termination, we showed that in the other pictures. 6 inches above the roof and at least 7 feet above the roof surface if the roof is accessible to people. Snow and debris, we talked about that. Protection in snow regions, vent pipes should extend above the expected snow level to prevent blockage, and open top should be protected with approved covers and screens. Also freeze protection. Location rule, vent terminals must be at least 4 feet below or 3 feet above any operable window or air intake. And sidewall vents must terminate at least 10 feet from the property line with screens to keep out pests. That's a big thing, to have the screens for the if you want to keep pests out. Trap basics. A trap is designed to keep sewer gases and airborne bacteria from escaping the drainage system and entering the dwelling. Each plumbing fixture should be separately trapped by a water sealed trap. And again, we showed the anatomy of a drain. When you talk to your clients, you explain to them, the trap is designed to trap water for what we're talking about. You don't want the sewer gases to come in. It traps the water in there, and that's what happens. We did an inspection one time for a little old lady that was selling a house, and she had a bathroom down there and probably didn't use the bathroom in years. And she said every time she went down in the basement, she went in the bathroom and she had this smell of sewer gases. And I said, when was the last time you used the bathroom? And, the shower. And she goes, we haven't used it for years. So we literally turned it on, filled up the trap, and the smell went away. She was like so impressed. But stuff like that, if you get a smell and you realize that fixtures haven't been used for a while, that water in the trap is going to evaporate, and then you're going to start getting sewer gases. So that's the main focus of that. Each plumbing fixture should be separately trapped and water sealed trap. We talked about that. Integral traps do not require any additional traps. So basically on the toilet one, that would be the trap is in the bowl, as you can see on that point. And again, good illustration of what you do on the toilet inspection. You check for any cracks. make sure it's not loose, you make sure it's connected to the floor properly, make sure no water's leaking around the base of it. Flush it a couple of times, make sure it's flushing properly. When you flush the bowl, if you get gurgling, like there's most likely a problem with the venting system on that. So you can comment on that. It could be problems with sewer line, those type of things. So that's, when you flush the bowl, it should have it should flush down nicely and smooth. If it starts gurgling towards the end, same thing with a bathtub. When you fill up the tub and you release it, you watch it as it's going down. Sometimes you'll see air bubbles backing up. There's a venting problem that you would definitely call it out. Minimum trap size, again, this is just reference to know when you're doing an inspection, if the sizes are not proper, at least you have an idea, what the sizes should be by looking at this. So if you're looking at dishwasher machine, domestic, it should be 1.5 inches. Stuff that you'll keep in your mind. You'll know that that's 1.5 inches. If you see one that's smaller, you know that it's not proper. Floor drains, good information. Again, on the InterNACHI website, all of this stuff is in there. If you're going for your CPI certification, you're going to go through all of this stuff, to get certified for that. So good stuff on that website. Prohibited traps, S traps, you want to call that out. Fixture trap must have liquid seal, kind of what we talked about for the functionality. You're not going to really know how much is in there because you're not looking in the trap, but just again, FYI, you can talk to your clients about it and explain that to them with a trap. The S trap would cause siphoning to come back, so you never want to see that. This is just more cutaways of, if you got the trap, how it operates on it's called a bottle trap. I don't see many of them anymore. I don't know about you guys on other states, but we always see the P trap. Okay, basics. Trap clean out defects, that's pretty obvious. Also, when you have a trap underneath the sink, that becomes your clean out. You can unscrew that and then the trap would dislodge and you can clean out if anything gets stuck in there, hair or anything like that, or stuff that would drop in there. So we got trap clean out. A clean out plug or removable trap section should be installed on traps located below laundry tubs, sinks, and wash basins used for cleaning. Inspector should check for traps under each fixture. Toilets never have traps. Leaks at traps are common due to loose connections or damaged pipes. In cold climates, check for traps that are subject to freezing. A common occurrence is when an unqualified person has unsuccessfully tried to repair a trap, which you see a lot. You see electrical tape, you see duct tape. Check for staining, water damage, and buckets, obviously. Again, if you look, you see things, it jumps out at you, you know it's wrong, take a picture and comment on it in your report. Many old tail pieces and traps are made of soft brass with chrome or nickel plating. They are sometimes so thin that a gentle touch will cause them to break into pieces. If you folks are doing inspections out there, a lot of times you'll see that corrugated drain. That's just basically, that's a temporary drain that a plumber would never do that. That's like a DIY that you need to change this and you're not going to start cutting and making it perfect. So they take that and they do it. What I do is I run the water and I take my flashlight and I shine it behind there and I show the clients that how all of that debris gets built up in that corrugated section, and you can clearly see the water flowing. Also, it's not as secure as you would have on a pipe system, whether it's PVC or copper or whatever. If you're moving stuff in and out underneath the cabinet, that you're not going to nick that and it's going to leak. It's a very thin plastic. I'm sure as you do inspections, you've seen them. I don't know if there's a picture in here of it, but no. This video, I don't know how long this video is, but again, we'll save the videos for the end. We'll get through the material, and we can always double back onto that. Bathroom inspection, so we'll just save that. Protection against pipe damage. This is, if you do drawer inspections or new construction and you're there before they close up the walls, a lot of times our clients ask us to do phase inspections as they're going along with their build. A lot of builders as well, they'll hire us to go in and do drawer inspections to look for these things while the wall is open, and then you can comment on them. But this is talking about how gas pipes and slabs, how they should be protected. You would see all of that during the construction phase, because once the concrete is poured, I mean, you'll have an idea if it's coming out on the termination points, but you don't know what's going on in there. So pipes located less than 1.5 inches from the edge of the studs, joist, or rafters must be shielded from damage caused by nails, screws, or fasteners. So that's something that if the drain or a pipe is going through and it's too close to the stud, then on the outside, they'll put those pieces on. I think we might have some pictures of that in the next one. Use of shields, steel shields, at least 1/16 of an inch thick, must be installed to cover and protect pipes where holes or notches occur in framing, which you see on that picture here. Shielded plates, fuel gas piping. For gas lines, the plate should extend a minimum of 4 inches above sole plates and to both sides of the studs or rafters to prevent puncture risks. So basically, if it's too close to the stud, or there's a possibility of putting a long screw in, you don't want to hit any of that. So those are the pipe protectors for that. And again, you're not going to see this unless you're doing a pre-drywall inspection. What do we got here? Fuel piping should never be embedded in concrete or masonry, as slab movement or corrosion can damage the pipe. Instead, it should be installed in channels or casings for protection. That's what this illustration is with the cutaway sections. You can see the conduit with the gas pipe inside. That's pretty much how you, if you were doing a construction, that's how it would be done. Fundamentals of plumbing support. Again, just information that you can refer back to if you have to when you're writing your report. If you want to reference things, this is a lot of stuff to memorize. I personally don't know it, but like this, but I would reference this if I had to. Again, we're not code. We're not looking for code. We're looking for functionality. Oh, great. A lot of times we go into a crawl space and this is what you see. So hangers and straps should be approved materials that will not promote galvanic action. We talked about that earlier when you have dissimilar metals. So if you're supporting a pipe with a dissimilar metal, it's going to cause corrosion, and that's where you're going to have leaks. Rigid support, sway brackets, piping should be supported at distances not to exceed those in the table. Again, you're going to use that, but a lot of it is common sense. If you don't see the proper support or this setup here, you call that out. You don't need to know the distance. It's just that's an improper support, and you would call that out and write it up. That's in a crawl space. Okay, so storm drain basics. Same thing here. Storm drains is the system of collecting and transporting away from the dwelling the rainwater, groundwater, and stormwater, which are typically associated with rainwater. So when you see this, you always put a comment in the report, keep exterior drains free of debris, because you never want this to clog up. And then like on this sliding door, you don't really have a threshold coming out. So anything that builds up is going to go in pretty easily. So you put these drains in, but you got to keep them clear, otherwise they're not going to do that job. Connection of floor drains to storm drain system is not permitted. Storm drain, rain, and groundwater should not be drained into sewer systems. They used to do this back in the day, in the boroughs where, we do a lot of inspections in Brooklyn and Queens, and sometimes the older houses still have this, where the gutters and leaders are going down into the sewer system. So what the city realized, that you're sending all of this water that doesn't have to be treated to the sewage treatment plants. And they were getting overloaded when you get heavy rains, and you'd have problems with this. So now that's not allowed anymore. The water runoff cannot go into a sewer line. It can go into a storm drain, which that gets dispersed differently. It can go into the bays and stuff like that because it's a storm drain. But yeah, we mention that if we see it. We talk to the client about it, because you really don't want to overload the sewage system with rainwater. And that's pretty much, the rainwater should drain to an acceptable point of disposal, such as retention basin, river, streams, ponds, public storm drains, or the land surrounding it. If you're on big property, and a lot of times they just push the water away from the house, and as long as it's going downhill, they're doing a good job. So what do we got here? Storm drain basics. Gutters and downspouts or other means should prevent rainwater from washing soil away from the dwelling foundation or building up around and increasing groundwater pressure on the basement walls. Talking about hydrostatic pressure here. The size of a drainage pipe should not be reduced in the direction of flow. So what they're saying here is, a lot of times you'll go to a house, and number one, if they don't have gutters, we call that out. And you can see, if you don't have gutters, you look directly below the edge of the roof, you'll see it's channeled out. You'll see it's all eroded from that water just running off the roof and hitting the ground. And then, of course, it builds up water against the foundation. It gets wet. That soil becomes heavy, moisture laden, and then you just get that hydrostatic pressure that pushes in. It's interesting, as we just did an inspection today, and we had the same exact problem. No gutters. It was actually the garage, and it was on a setup where the terrain was, the garage was below, and the neighbor's yard literally went all the way up, and they had no gutters. They couldn't even get to that side, and the whole wall was pushed in because of that simple fix of getting the water away from the house. That's important. Water management. How is water being diverted away from the house? Okay, so now, as the other part of the plumbing inspection, we talked about the appliances earlier. So one of the areas of concentration you're going to do on the dryer is the exhaust vent. You never want to see a dryer vent discharging into, crawl space like you see here. You also want to make sure that the vent is not clogged, and you get flow. What most people fail to understand is that this lint from the dryer is highly flammable. So if it's in the basement or in the crawl space, it's a potential fire hazard. So whenever we see this, always call it out and get it corrected. And then the materials that are used, you don't want to use the plastic vents anymore. You want to use, the best is if you have like on the dryer part here, you could see where you have the flexible, and then it goes to a regular pipe going out. So this is the metal part down here. No plastic. If you see plastic dryer vents, call them out. That's important. Closed dryer vents emit exhaust air that is laden with moisture and lint. So that's a good point too. Not only the lint is flammable, you're putting moisture back into the living space, which you don't want. So all the dryer vents should exhaust to the outside. Right there must be discharged. You'll also see this in attics. Sometimes they discharge them into the attics if the dryer's up on the second floor and you got the attic above you. you don't want to do that. Not a good idea. Dryer exhaust duct fitting type, 4-inch radius, 2.5 feet, 4-inch radius, 5 feet. The maximum length of the exhaust duct does not include the transition duct. So again, the more bends you have in piping, it's going to restrict the flow. So you want to have the minimal amount of bends or curves in a dryer vent. Let's see what we got here. Termination points. The duct termination should be fitted with a closable gravity or automatic damper, a backdraft damper. Exhaust outlets should be equipped with backdraft dampers to prevent cold air, rain, snow, rodents, or animals from entering. So that would be like the louvers that you're looking at over here on the outside. And you want to make sure they're cleaned out and not restrict the flow. The dryer exhaust should terminate not less than 3 feet in any direction from opening into home, including operable windows, doors, and air intakes. The exhaust duct should terminate outside the home, at least 3 feet from any opening and at least 10 feet from any air conditioning or heat pump condensers. You don't want to be pumping hot air into, your air conditioning stuff outside. So that's not helpful. Ducts should be sealed and mechanically fastened. Ducts should not be joined. Connections, you don't want to see screws or fasteners because that's going to catch the lint. Ducts should not extend into or through ducts or plenums, right? So you don't want to go through a duct or a plenum. You want it to go directly outside. The exhaust duct should not be minimum of 4 inches in the exhaust duct should be a minimum of 4 inches in diameter. Transition ducts should not be concealed within construction material. You want to see that dryer vent all the time. If it's behind a wall, you don't know if it's leaking, and you're not going to know. So you always want to have it exposed. Okay. Okay, so now we're getting into the good stuff. As part of your plumbing inspection, we talked earlier that you have to identify fuel storage tanks and stuff like that. So when you're dealing with oil, it's a big responsibility to have it, if you have it on your house, you're responsible for that oil. If it leaks, whether it's underground or even in your house, it becomes a contaminated site if you get enough. We've heard horror stories that tanks just leaked all over the place in the house. It's not good. So as part of your inspection, knowing where the fuel storage tanks are located, up here in the Northeast, and again, I guess you guys, and if anybody's here in the South and Florida, any places like that, you're not really dealing with this. But this in the Northeast, in New York, this is a major concern for us on inspections. We have to identify where these tanks are, and if they are located in the ground and they're not abandoned properly, the suggestion to your client is to talk to their attorney, but you don't want to, if the tank is in the ground, most likely it's an old tank. So you have the potential for leaks, contamination. And if your oil tank leaks into your neighbor's property, it's a big, big problem. So anytime you're dealing with fuel storage, especially oil, it's a big responsibility having it on your property. So don't miss these certain things on inspections for that. That's important. All tanks must be listed and labeled and confirmed with standards. That's talking about underground. Maximum amount of fuel oil stored above ground or inside a dwelling should not exceed 660 gallons. We've done houses where they had multiple oil tanks outside, anywhere excess of 1,000 to 1,500 gallon. They had multiple 500-gallon tanks in the ground, and just an absolute nightmare. So be very cognizant of your inspection to deal with this potential buried oil tank or even an old tank. I mean, this tank we're looking at in the middle is in a basement. Clearly, not only the tank is corroded, you can see the legs are corroding. You don't want that leg to fall or yeah, you got to be really diligent on anything that's dealing with oil. Inside out night supply vents, exterior above ground oil. Okay, so basically, if the tank is inside, no, this is above exterior above ground oil tank storage. Okay, so this one is above ground and it's outside. So these are the requirements if you have an outside oil tank, obviously a fill in event, and then the line comes through the foundation wall and you got a fuel shut off, usually at the filter. Ones inside usually have it underneath the tank and at the filter. But this is a good illustration of an above ground oil tank storage system. Inside and outside oil tanks for inside dwelling should be of such size to permit installation and removal from dwelling. A lot of times you go on house inspections and these oil tanks are in the basement, but they're behind finished walls. We literally can't even look underneath it or inspect it. If you can't do that, you have to put it in as a limitation. Sometimes they just have this little cutout so you can read the gauge to see how much oil you have in it, but you can't tell anything about the oil tank around, the underneath or the sides because it's finished. And the other conversation I have with the clients is that if this is behind the wall, in order for you to change it, you have to take this wall down. And people do strange things and it makes it difficult to access. So if it's something behind a wall, I would highly recommend discussing that with your clients. Tanks located outside and above ground should be at least 5 feet from an adjoining property line. Okay, those are your setbacks. Usually they're close to the house. Tanks located outside should be protected from weather and physical damage. A lot of times you see oil tanks outside, they don't have a covering on it. If you see that, call it out. Recommend to the client that they, cover the oil tank to get it out of the weather. Fuel gauges, they have to have a gauge on it so you can read it. In areas prone to flooding, tanks should be installed at or above the flood elevation or should be anchored to prevent flotation, collapse, or lateral movement under flooding conditions. So, yeah, that's all stuff that when you do your inspection, you look for that. Oil tank defects, areas of leakage. Pretty common problems include leaks at oil tank. You'll smell it. There's no doubt when you go into a basement, if there's an oil leak, you smell it. Improperly supported legs. We talked about that with the rust on that leg on that tank. Corrosion at the tank. The other thing people have to realize, and you could have this conversation with your clients, oil tanks rust from the inside out. So if it's in the house, the contamination from the oil and some of the oils have, moisture in it, it collects and it'll rust from the inside out. So you could be looking at a tank and there might not be signs yet, but if it's an older tank, if it's welded on the sides, it's an older tank. If it doesn't have the handles, the newer tanks have the handles. So you can understand that. Just be aware that some of these tanks are old. And one of our comments in our report writing is whenever we see an old oil tank, we put in old oil tanks are prone to leaks. So that oil tank is 30, 40 years old. It looks great, but it could be rusting from the inside out. So that's a good comment to add to your reports. And it helps you out with your client's understanding because you could have an issue, a year or so down the road. And, just that's a good comment to have for your report writing. Let's see, that's oil underground and support for fuel gas piping. Okay, so gas supports, we're talking about the rises, the vertical supports, foundation wall where it comes through, the horizontal support. They have to be supported, depending on the diameter, that'll be the width and how far apart they are. But again, you'll look at it, you'll see the pipe, you'll know if it's not supported properly. Basically, you want to know that gas pipe is being supported properly at the critical points. A lot of times, I don't know where everybody else is, but up here in the Northeast, they're running plastic copper lines in the ground, and then they just connect it to the steel piping above ground. So a lot of times you'll see the gas piping coming up underground, and you're going to see a wire coming up. You can explain to your clients that that's called a tracer wire. So if they're looking for this gas pipe in the ground and you can't pick it up with a metal detector, they wrap the wire around it. So when they're checking where the gas line is, they can pick up on it because the wire has metal in it and they can see it. So when you go to the gas meter, if it's that situation, you'll see that tracer wire coming up. So a lot of times people ask what that wire is for, and you can explain that. That's helpful to know when you explain that to your clients. Fuel gas sediment traps. So basically, what happens is sometimes there's debris and sediment in the gas. So what you want to do is you want to see that sediment trap at the T feeding the regulator on the gas pipe. And then obviously with the trap on the bottom, all that sediment would go straight down and it wouldn't go into the gas, valve and regulator and create a problem. Sediment trap, vent connector. Again, all good terminology to know when you're writing your report. The vent connector, that's the one that comes out of the water heater and then connects to the vent going into the chimney. Cold water supply, we talked about that earlier. There's a shutoff valve for it. So you can see how a lot of times what we're talking about things, they're reappearing in different aspects of the course. You want to call that out on the shutoff. If you remember when Jim was talking about backdrafting, those plastic pieces that identify hot and cold, you'll see them melted. It's backdrafting. You want to write that up. All important stuff as an inspector that you should identify and look for as you're doing your reports and your inspections. Draft hood, you got to make sure that's lined up properly. You have to have that space underneath it. A lot of times we go and they just screw it down to the bottom and they don't have that. It's not right. One of the biggest challenges we're seeing is that when you replace a water heater, a lot of times the water heater is taller than the old one. And what happens is that where that vent connector is, it's going to vent it out into the chimney. You'll see it back pitched. When you're doing an inspection on this, be sure that you're looking at the pitch of that pipe, because unlike the waste line, if it's not pitched properly, things are going to back up because it's solid waste on the sewer line. But now you're dealing with gas. You're dealing with, a poisonous gas that it always supposed to be sloping up. So if you go, carry a little level with you, put it on there, take a picture, show it's not level, point it out to your clients. You'll see people put in bigger water heaters. And what happens is they don't want to change that connection going out into the chimney because it's a lot of work. And you will find vent pipes that are back pitched. So be aware of that. That's important to look for when you're doing your inspection. What do we got here? Fuel sediment traps. We talked about that sediment trap design to turn the gas flow 90 degrees at the sediment collection point. So where is a sediment trap? So that's what they're talking about. You don't want it here. You want it on like this slide, right down here on the bottom, underneath that T that we talked about earlier. You don't want to see this. If you see this, you have to call it out. Actually, this is a good schematic of what it should look like, because your gas supply is coming down, it's getting teed off, going into the water heater, and then there's that little length with the cap on the bottom. That's where all the sediment would go. So if you see something like this, call it out. What do we got? Appliance shut-off valve. Okay, so on this, fuel sediment traps, basically what we're talking about, then there's always a union where if it's a non-movable appliance, you have to be able to disconnect it from there and do it. Connection capacity must be greater than or equal to the input rating of the appliance. This is all figured out when they install the appliances, but shut-off valve at the appliance, whether it's a water heater or a furnace or anything like that, anything that has gas, you have to have a shut-off right at that point. And then a union, some places it's required, some places it's not, but at least you have that. If it's non-movable appliance, you can, disconnect that if you have to. Fuel gas pressure regulators. A line pressure regulator should be installed where the appliance is designed to operate at a lower pressure than the supply pressure. Access should be provided to all pressure regulators. You want to be able to get to them. They should be protected from physical damage. Pressure regulators that require vents should be vented directly to the outdoors. Now, here, when we have a gas meter that's inside the house, you should see that vent going outside the house, because high pressure gas, there's a regulator on it. So if there's an overpressurization, it'll go through that regulator and it'll wind up going outside and vent to the outside. So that's important. If you come across a gas meter inside the house and you don't see this, I'd be shocked, because the gas company's all over that. And, unless it's real old, look for that. And you'll see it outside. And it's a good conversation piece when you're walking around the outside with your client. You point that out to them and say, this is a gas, the vent for the gas pressure regulator on the gas supply. And then when you go inside, you could show them that pipe going out the wall, and you show them where the gas meter is and the regulator, and you highlight your knowledge with them. That's always a good thing. Shut-off valves for fuel gas appliances. Each piece of equipment and appliance should be provided with a shut-off valve, which is separate from the appliance to permit maintenance, repair, or replacement. It should be no further away than 6 feet, located and within, obviously, the area. Shut-off valves should not be located in concealed locations. Doesn't do you any good, and shall have access provided. Should be easily located and operated in the event of emergency. For example, a gas shutoff valve for an appliance on the first floor should not be located in the basement. There's an exception for decorative appliances. A shutoff valve should be installed ahead of the flexible semi-rigid appliance fuel connector. You'll see that one, the gas connector, it's flexible. It's going to be before it gets to that point, because you want to be able to shut that off. Gas outlets that do not connect to appliances should be capped tight in case the shutoff valve opens or fails. Sometimes we go to houses and they disconnected the appliances. The gas valve is there. Just like we said, the cap has to be on it in case somebody opens that by mistake. You don't want gas coming in the house. So if the appliance is disconnected, you want to see a cap. Even though you have the shutoff valve, you want to see a cap on that business end of the pipe. Okay, so fuel connectors, gas appliance connectors, basically giving you an overview of what we were talking about. connectors cannot be concealed. This is more of a diagram of it. You want it visible and accessible. Shut-off valve cannot be in a different room. We talked about that. We talked about the outside. If you look at the diagram, there's this is outside, but the pressure regulator is that piece on the left-hand side, the pipe coming up out of the ground. Usually pressure regulator is right there. If this meter was inside the house, you would see the pipe coming through on the outside as a vent. So it's vented to the outside. Fuel gas venting systems. Connectors should be used to connect an appliance and equipment to the vertical chimney or vent, except where the chimney or vent is attached directly to the appliance. The vent connector should be as short as practical, and the appliance should be located as close as practical to the chimney or vent. So you want to get everything close to where it's going to vent out. You don't want to have excess runs, or sometimes it happens, but the best situation is right there. If you go into a boiler room, usually the chimney is right behind it. The boiler will vent out, the chimney will vent out, the water heater will vent out into the chimney as well, and it's close. You don't have to worry about that long run with the piping getting dislodged and stuff like that. All vent pipes should be listed and labeled. The type and size of the vent for each fuel gas appliance are dedicated by the appliance manufacturer's installation instruction. The appliance manufacturer is going to tell you what size needs to be used and how it should be done. Type B gas vents, single wall metal pipes, type L plastic vents for category 4 appliances, and type BW for vents. All different types of vents that are used on different gas appliances. Insulation around chimney. Let's see what we got here. So you don't want purpose insulation shields are installed in attics. So this is the insulation shield up in the attic to prevent insulation from coming in contact with chimney or vents, maintaining safe clearance and reducing fire risks. So a lot of times you'll see that chaseway in the attic. Those are the things you want to look for. The box, keep the insulation away from it so that chimney can do its job without having in contact with that hot pipe. Shield should be made from at least 26 gauge steel metal to provide durable separation between insulation and venting systems. The shield must extend at least 2 inches above the insulation and be securely fastened in place to prevent displacement or gaps that could compromise safety. So that you'll see up in the attic when the chimney, when the metal pipe is going through the attic. Okay, so now we got factory-built chimneys and fuel gas. A factory-built chimney should be installed according to manufacturer's instructions. All prefabricated chimneys must have a label from an approved agency. The label should state the type of appliance with which the chimney was tested for use, a reference to the manufacturer's instruction, and a minimum clearance to combustibles. That's what we were talking about in the previous slide. The manufacturer's instruction should contain every aspect of the installation of the chimney, include component assembly, clearances, supports, terminations, fire blocking or fire stops, and connections. Chimney vent connectors, we talked about that earlier. So that's going to be the vent connector coming right off of the appliance, and then it's going to be attached to the vent itself going outside. Those are the things we were talking about earlier to look for. You want to look for corrosion. You want to make sure it's pitched properly. And that's important. The smaller appliance vent connector should connect to the chimney above the larger one. Sometimes you see a little weirdness and it's not, but if it's done the wrong way, you should call that out. That's a good diagram of it, of how it should look. Obviously, the furnace is a bigger appliance. It's venting out below, the water heater is above, and that's all looking good. Fuel gas vent termination. Let's see what we got here. Okay, so they're giving you some ideas of termination clearance of mechanical draft and direct venting systems. So when you're outside and you're walking around and you see that PVC coming out, we talked about that earlier on the tankless systems. You're going to see the PVC pipes coming out for the exhaust as well as the fresh air for that sealed combustion to function properly. So these are just some ideas and measurements of where they should be located. If you see it, close to a window or underneath the window, definitely comment on it. And again, if you go through the course, you'll pound this into your head on the distances, and a lot of times you just look at something, it's wrong. But types of venting system to be used in appliances, they talk about it. Categories, type of venting system, type B vent, chimney, single wall, metal pipe, special gas vent listed for appliances, all different types of things. Regardless, all appliances must be connected to venting systems. The venting system must never extend into or pass through any fabricated air ducts. We talked about that earlier, or furnace plenum. It must convey an adequate positive flow of flue or vent gases directly to the outdoors. That's why you never want to see that flue pipe back pitched. Okay, clearances versus fuel gas vent clearances. Okay, types of venting systems. There are several types of venting systems that can be used, including plastic piping, special gas vents designed by the manufacturer, and masonry, metal, and factory-built chimneys. So depending on the appliance, the manufacturer is going to recommend the materials and all of the applications for the venting. That's a good illustration to show how, the airflow, and then obviously, you got a 10-inch radius from the roof. This is all good stuff to look at and understand. That kind of, I think there's a roof slope height. Yeah, that's good. B vent termination, how it is, the clearance above the roof. So that's all good stuff. There are several types of venting. Yep, we talked about that. Let's see what we got here. Chimney, masonry, and fireplace termination. It's a common mistake to apply chimney masonry termination height requirements, the 3-2-10 rule, to gas fuel vents, which causes vents to extend above roofs much higher than needed. In most cases, for example, gas vent pipe terminations above roof slopes up to 612 need to be only 1 foot high. Gas vents that are 12 inches or less in size and located at least 8 feet from the vertical wall or similar structure should terminate above the roof. This is kind of a good diagram of what we're talking about. Automatic dampers. Okay. So on a flue pipe, you're going to see this damper system. When you're doing your inspection, you want to make sure that it moves freely. It's not stuck. It's not broken, because this is going to help balance out the airflow. And when the heating system starts up, the pipe the vent is not hot enough. So this kind of regulates it. So your main purpose is on these things to make sure they're functioning properly. You'll always see this one on the right, you'll see it on the flue right above the appliance. Just want to make sure it moves freely and does its job. Automatic flue damper is an energy-saving device that uses off and restricts an appliance flow with appliances is not operating and is in the off cycle. Right, so like I said, it closes and then it does its thing. That's the automatic one. Manual damper should be used only with a solid fuel burning appliance and not with a gas fired appliance. The use of solid fuel burning appliances would be aware of a closed or malfunctioning manual damper because of the smoke. So depending on the dampers with the appliances, again, it's going to be the manufacturer's recommendation for those various appliances. AJ, believe it or not, that was the last slide. Again, this is a quick slide of us. We're located on Long Island. We service all of the boroughs, Manhattan, Lower Westchester. Very simple. If you scan my QR code, feel free to call me anytime. If you have a question or a concern when you're out in the field, I really enjoy sharing as much knowledge and education as I have with fellow inspectors. So feel free to call me up. Shoot me a text. I'll be more than glad to get back to you. Like I said, we're based, as you know, we're all inspectors. Our car is our home office. So we drive around all the time and I have a lot of time in driving. So I'd be more than glad to respond back to a text or a question if anybody has. And that's us. That's who we are. You saw from the QR code, you can scan that. You'll get my information. And, if we could wrap it up, we're good time-wise.
Yep. Just tell
All right,
everyone
thank
good night.
everybody for joining us. Next week, we're going to be doing safe practices for home inspectors.